Okay, so my name is Andrew Childs, and I'd like to tell you about CS 467, which is an introduction to quantum computing. This is a course that is going to be offered next term. I'll be teaching it, and it's currently scheduled to be on Tuesdays and Thursdays from 10 to 11:20. So this course is an introduction to quantum computing. So you probably know that quantum mechanics is a theory of physics which describes the behavior of systems like atomic systems. And what was realized fairly recently, actually, starting in the 1980s, was that if you think about a theory of information processing, which is built on the principles of quantum mechanics, then there are certain kinds of tasks that you can solve either a lot faster, or some tasks that you couldn't solve at all if you were only using classical information. So the idea of this course is to explore this model of quantum information processing and to look at some of these applications where you can do something a lot better taking advantage of quantum mechanics. So for example, we'll talk about a quantum algorithm that can be used to factor integers in polynomial time, and this is something that we don't think we can do with classical computers. So this course is intended for students in different departments, not just in CS. It's intended for students in CS, C&O, and physics. And it's normally taken by students in their fourth year, but it is possible to take it earlier. So if you're interested in taking this course, say in your third year, I would encourage you to talk with me about it to see if you're prepared. The only prerequisite for this course is that you should be comfortable with linear algebra. So for example, if you did well in Math 235, then I would say you're well prepared to take this course. So linear algebra is really essential, but it's not necessary that you've seen quantum mechanics before. So if you haven't taken a course on quantum mechanics, or you don't even think you know anything about quantum mechanics, that's okay. You'll learn a lot about quantum mechanics by taking the course, but you don't need to know anything about quantum mechanics going in. Okay. So here's a rough outline of what we'll talk about in the course. We'll set up this model of quantum information and talk about how you can build quantum computers, how you can build computers out of quantum mechanical components. We spend most of the course talking about quantum algorithms, so talking about problems you can solve fast with quantum computers, but we also talk a bit about error correction, so how you can correct errors that crop up in quantum computers, and a little bit about how you can actually build quantum computers. This is very much a topic of active research these days, especially here at Waterloo. And at the end, maybe time permitting, we'll talk about some additional topics. So how are you evaluated in this course? Well, typically, the majority of your mark will come from assignments, something like 60% from maybe 5 assignments. There's usually a midterm exam, which will be 20% of your mark, and a final project, which consists of reading something in the research literature and writing a paper about it. Okay, so that's it for the course. So I just want to mention that if you get interested in quantum information, possibly through taking this course, there are a lot of resources here at Waterloo if you want to take things further. So there's something called the Institute for Quantum Computing at Waterloo, which is one of the largest, if not the largest, research centers in quantum information in the world. So that's something you should really take advantage of if you'd like to learn more about quantum information. There's the possibility to do undergraduate research projects. And we also have a lot of graduate courses that look in more detail at things that would go beyond the kind of material that you would learn in CS 467.